Okay, hey everyone, welcome to the continuation of lesson 21-4. This is video B, and we're going to be specifically focusing our work with probability here in this video on two-way tables of data. So you can see at the bottom of page 1121 that we're at right now, we're going to start here with example 1. So we're using the given two-way table to determine the probability that we have here. And with example 1, let's just explain what this table is basically saying. Okay, we have a category going across the top row, which is dealing with what class are the individuals in. And at the end of every row, you will see a total. And at the end of every column, you'll also see totals for each category. So if we wanted the probability of a senior or a girl, we're going to focus on the total categories, okay, and make sure that we're taking the correct list or the correct numbers there. So to find the probability of senior or a girl, first we're going to determine the probability of senior, just seniors in general. So in that case, we're going to look at the total number for seniors, which is 202. And the probability for girl, which would be going across this second row here, which would be the total at the end of that row for all the girls, no matter what class they're in, and that's going to be 412. Okay, so if we take a look at, so here I am, you guys, at the top of page 1122 or 1122. And what we're being asked to do again is to find the probability of a person in this two-way table being a senior or a girl. So the probability of girl we got already on the previous page, and that was, if you take a look at our table here, girls was 412 and seniors is 202. Those are the values that we circled. So of course probability is always going to be out of the total, and the total, you can see here, matches the number in the bottom right hand corner always of that two-way table. So we have 202 out of 808, and the book again reduces that fraction for you, simplifies that fraction for you. Again, I'm going to stress, I think that it's important that you wait until the end to reduce it. That way you're always working with that common denominator like we said in the first video here. So we have probability of a senior, probability of a girl, and then from that, because these are overlapping events, because if we look in this table here, we can see that it is possible to be both a senior and a girl, and that's in this section right here, this column of seniors, and row of girls overlaps at the value of 108. So that's the value that you see right there. 108, again, still out of the total, 808, and we're basically going to put all those pieces together, take senior or girl, which is going to be probability of a senior plus the probability of a girl minus the probability that the outcome is both a senior and a girl. So we get 253 out of 404 as we reduce there. My calculations here for you guys, just to kind of show you how I would do that with keeping a common denominator until the end. I would do this. I would say, okay, here's senior, which I know is 202, plus the girl, which is 412, and then minus the senior and girl, which is 108. That's what I would do as far as calculating that out, and then I would go ahead and simplify my fraction at the end here. Okay, so that's how you use a two-way table, you guys. Part B gives you another one where we're kind of filling in, and then of course we have a your turn coming up next. I'm sure you can probably guess there. So let's take a look at part B. Be careful on this one. The probability for B that they're asking you for is, what is the probability that you're getting domestic or late? And notice this little C up in the upper exponent almost. It means complement, remember. So a reminder that complement means not domestic or late. So we're going to use our addition rule to determine domestic or late first, and then we'll take the complement of it. So the probability of domestic is, oops, sorry about that. Probability of domestic is 120 out of 180, simplifying that to 2/3. The probability of late is, if you look at the table, the late flights are in this column, and the total number of late flights is 18, so that's your 18 out of 180, which is the same thing as 1 out of 10. And then remember, we also want to subtract from that the probability of getting both a domestic and a late flight, and the domestic late flights are in this cell of that two-way table, so that is 12 out of 180 that we've kind of counted twice here, so reducing that to 1/15. And then again off to the side, I would just keep all the denominators as 180 until the end. So 120 plus 18 minus 12, all out of 180. And that, of course, works out to we would get 126 out of 180, and I would remind you guys to take a look at your math key on your calculator and use the math fraction key to reduce that 126 over 180, and that comes out to be 7/10. Now, lest we think we're done, remember we have to go back and talk about this idea of complement, okay? So complement, remember, is the probability of not being domestic or late. So if the probability of domestic or late is 7/10, then the probability of not domestic or late is going to be calculated by using our complement rule. And I'll refer you guys back to 21-1, the section where we talked about the complement, which remember was the probability of something not happening is 1 minus the probability of it happening. So since we just found that the probability of domestic or late was 7/10, we can do a simple subtraction from 1 and get that our final answer in this problem part B is 3/10. So I would like you guys to go to the next page, 1123. And on this page you only have one your turn this time around, but please make sure that you do number 5 before you come back to class. We'll see you guys next time.